Well, I've pulled the bottom chassis out. Fairly easy, although I didn't kind of make these leads long enough. I mean, there's no way I can connect the EHT lead or even the yoke. I can just connect the yoke up when the whole bottom trough is out. Yeah, just a case of taking out a bolt there and a bolt in there, and the whole thing pretty much just sort of lifts out. So yeah, now we can sort of look at the area in question, which is down here. As you can see, there are electrolytics and capacitors buried underneath those resistors. And it's going to be a case of just having to actually lift these components out one by one and replace the parts as necessary. Yeah, it's kind of a pain in a way. I'm not sure what's pulling that 150 volt line down, but there's a 2.2 mic cap, which is part of the brightness circuit, which is right here. That cap's leaky. It could be pulling that supply down, and the fact that it's tied up with the fact we've got the fact that we've got bugger all brightness, or literally no brightness at all, yeah, kind of points to it could be that capacitor that's leaky. Yeah, I'll check all the associated resistors around it as well, and I'll check that. Check these two as well. I think those are those two Phillips mustard caps down there, so they'll be perfectly fine. And I've got a box here of new old stock electrolytics I can put in this thing, because that 2.2 is an actual one. And I've found these quality looking Riken chemical capacitors. I don't know if these are any good. Yeah, these Riken chemical caps. These are basically new old stock, like all the other caps in this bag. And yeah, these came from a very good friend of mine who passed away about a year ago. So yep, he left me with a whole lot of components I'll probably never use in my lifetime, but hey, that's just the way it goes. So I'm going to chuck this on my capacitor bridge and see if it actually forms or reforms. And if it does, I will definitely use some of these components. I did check these on my bridge, and they actually, these Plessy ones, and they actually 1 mic 450, and they formed up perfectly fine. Don't know whether that would. Yeah, these are a bit getting a bit past it. You found these Phillips caps to be quite good too. They seem to hold up. Oh, mind you, looking at that, that's generally a sign of the rot starting. But yeah, some of these Japanese ones are okay. Seems to be some of the smaller oil-filled caps of this Japanese flavour that they used in the Sansuis and the Pioneers and the Kenwood receivers of the 1960s gave grief. But these high voltage ones seem to be okay. Likes of these would be okay, and these you find these Elners too. They seem to hold out and hang on. You know, I probably wouldn't, if I was restoring a customer's set or a TV, I wouldn't put these in. But for myself, you know, it's me, it's moi. You know, I don't. You know, oh look, Daewoo. There's a Daewoo on there. Huh. I remember seeing the first Daewoo cap. I remember seeing these Daewoo caps in a Samsung 14-inch TV about 20 years ago. I think they made cars, or did make cars. I don't know if they still do. But this bag of, oh bloody hell, 10 mic 450. Christ, I'm definitely swimming in these high voltage caps. 10 mic or 500. That's, you know, more than adequate for vintage projects. So yeah. But yeah, so I think I'll start with replacing the components down in there, which are associated with the 150 volt line, and these two 0.047s. I'll change those and check the associated resistors, and I'll change that 0.15 down there. And there's also a big electrolytic down here too. I don't quite know what value that is. Trying to turn it before. Hang on, we'll see if we can twist it around without. We'll probably, no doubt, we'll probably snap the leg off it in the process, just to irritate everybody, or myself actually. Hang on, what value this is? It's not going to let me, is it? No, hang on. It is a something or other. It's a British-made thing, so it'll be past its use-by date, no doubt. It is a something microfarad. It's like a 50 or an 80 microfarad. 80 microfarad. Oh, now that cap is, where did I see that cap? There'd be that one there. 80 microfarad. Yeah, basically it's supply, smoothing and supply to the vertical output transformer. So it'll be that bugger there. It's probably alright at this stage. I said I'll just want to get the picture back first, get a decent raster, get some brightness onto the screen before I start looking at other things. But yeah, alright, well I'll guess next time you'll see an update, there'll be some new components down there, and hopefully we might get a slightly better results from it, and yeah, because that's the 60 microfarad filter on that line too. I'm probably going to temporarily tack a 100 mic or 47 mic across that temporarily, but I think the main priority is to sort down here out first, and we'll take it from there. Right, that's about a small update for now, so stay tuned for another installment at some stage. Cheers. Excuse the crap lighting, but I thought I'd show you my capacitance bridge, which is down on the floor under a table because it's the only place it can fit there in the workshop. Yeah, this is the 2.2 microfarad cap in the brightness circuit, and I believe I found the culprit because this is actually testing quite leaky, and I'll demonstrate in a second. But yeah, just thought I'd actually show you guys this thing first. It's a British Physical Laboratories Bridges Capacitance number 2 Mark III. Yeah, don't know how rare this is or how many of these were made, but obviously it was a serious bit of kit back in the day. The beauty with this, it can actually test. It can test from 1 microfarad to 1,000 mic. I think it does I think it goes up to 2,000 microfarad, but you can basically check electrolytics on it, which is really handy. I've had this thing for probably about, I don't know, 20 odd years. Got it from a radio junk cell. I think or somewhere, or even a ham junk cell would have come from at some stage. But yes, it's actually been a very handy bit of test equipment. I've reformed quite a few old capacitors and even checked some of these high voltage caps for leakage as well. Does it up to 600 volts. So 600 volts, and it's got 3 scales. Goes up to 50 mils of leakage current, and you've got 0.5, 50 milliamp, and 5 milliamp. So you've got 3 scales there, a discharge, and a read button on there, because that's where your capacitor goes. There's your multiplier. That's your sensitivity to balance the meter. Indicate 0, that indicates null, and then basically you pretty much read the capacitance using whatever the two scales indicate. Yeah, so very invaluable piece of test gear actually in some respects. So yeah, the Riken chemical one, this one here, this new 2.2, formed up absolutely perfectly. Didn't think much at all, but this one here is yeah, so I'll show you. So at the moment I am on the, sorry about this, I'm just moving around here. The cap's rated for 200 volts. I'm just on 200 volts at the moment, and I've got it on the 50 milliamp scale. So if I go to read, it's kind of, it was kind of before it was climbing, and the cap is actually yeah, the cap is actually getting quite warm. I mean, it's supposed to be at roughly about 200. It's drawing about 5 mil, but before it was up here, up at 20 milliamp, and it was getting quite hot. It seems to be holding. Yeah, I thought it would have actually have. It's drawing 5 milliamps of leakage current. It's stable. I mean, even if I try and increase the voltage a little bit, it shoots right up. So yeah, that cap's definitely drawing a bit of current. It shouldn't be doing that. It's definitely very leaky. It's obviously trying to reform. It's actually sort of getting quite warm as well. So in regards, if I put, so I'll put the new one on there, which is this one here. I'll put the new one on. The Riken Chemical High Qual. And make sure we get the polarity right so I don't blow it up. Where's one there? And I'm trying to do this one-handed. And one on there. That's right. And we'll flip the switch. We'll go up to 450 volts, which is what the cap's rated at. And look at that. There's not even a... That's 0.5 of a milliamp. And it's virtually nothing. With this meter, when the cap's reformed, it pretty much sits between sort of 0 and 5. That cap's perfect. It's perfectly formed. So yeah, I suspect this is the culprit. This is why basically what was happening is the probably the power supply was trying to reform this cap and circuit, and obviously the associated component electronics just wasn't quite up to the job. But no, before this cap was drawing a lot more current, and it was getting very, very hot to the touch. So I'm guessing that's more than likely going to be the problem. So I've cut it out of there. So I've cut it out. Oh man, I used to fix TVs on the floor back in my apprentice days. I've just been down there for about 10 minutes, and I'm really feeling it now. But yeah, so it's yeah, so it's just in there. So I will replace it, and again replace those two. I'm probably repeating myself again, and we'll see what happens. So yep, just give you another little update. Might even see if I can join these videos together rather than having two little separate updates, but we'll just see what happens. All right, back soon. Here is a bunch of crap. An utter bunch of crap. Shit components, shit resistors, and basically shit. Yes, I do occasionally swear. Normally say the F word, but not normally on when I'm filming things. But definitely some few F words were muttered when I did this. So this is where I'm at with it. Most of the components replaced. Ones that tested okay were left in place, like some of these carbon comps were still okay. The ones I've replaced were probably more crucial ones, and you know, that was a mile out. That was a mile out. That was a mile out. Yeah, some of them actually tested better in circuit than out. And of course that bloomin' culprit there, that one that was smoking and getting hot and causing all sorts of fun and games in the beginning, that's that one there, and that's the other 0.047 parallel off that. The line stage, there was a 0.1, 0.15 sitting at the back over there. So yeah, a bit of a bitch to work on. Can't say it was their finest moment in the design sector, but yeah, literally I had to like virtually take most of them out to change the two 0.047s and the 2.2 electrolytic down in there. You can probably just sort of, it is down there, it is hiding, and the one under here as well. I tested this one here too, and yeah, incredibly leaky. So yeah, this must be in Australia. There you go. I think that's is it a Pommy one? Yeah, the English one, I think it is. Yeah. But yeah, and it was actually quite nice to use my hundreds and hundreds of resistors I've got in stock, these big 1 watt resistors that I've got. So it's quite nice to use those. Now begs the question, will it go? Will it go up in a cloud of smoke? Will it go bang when I turn it on? Will it not go at all? Will I still have no picture? Have I got a naked tube? I don't think so. It's been about a week since I last did a video update. I've come out here during the week, this last week, and sort of done a little section at a time. Just finished off these easy ones, or the ones I basically started at the arsehole end and worked my way back. So yeah, that 4.7k resistor did about 5 something, and I've got quite a number of these Philips wire wound resistors. I think that one's a 5.5 watt. I'm guessing that's probably a maybe sort of a 2 watt, 2 or 3 watt. I don't know, but it's fairly large, probably a couple of watts. So yeah, just to kind of keep the heat down as well. So hopefully that doesn't get too hot. But yeah, I don't know what's going to happen. Certainly hope we do get some improving anyway. I'd like to see at least a raster that doesn't fade away after a couple of minutes. I mean, I'll be very surprised if we don't get any improvement at all, to be honest. So yeah, let's turn it on and see what happens. Might just hook up my meter again this time. Move it there. Hook my meter back up. Daylight savings has officially ended too. Actually, that was last weekend. So it gets pretty much gets dark at about 6 o'clock or thereabouts. So definitely, what is the time? It's 8:45. It's definitely dark outside. Right, he said with anticipation. Might actually hook that up. Might be an idea rather than getting 15 kV up my arm when I reach in to find out why I'm getting no picture. We'll start measuring things. I mean, they could have made it a bit longer, eh? That's, like this bloody coaxial cable coming from the tune of the eye. They could have just made it a little bit longer. But maybe they were told to do that, cutting down costs, if we use an extra foot of wire, it's going to cost the company thousands of dollars or thousands of pounds way back in those days. So I have to pull that back there and hook that up. Plug that back in. I've already plugged the yoke back in, and the tube base plug that is back in. Right, now the fun part. The bit I don't like. I'll turn it on with reduced mains. So what have we got? About 182. It should be fine. Right, let's turn this bugger on and see what happens. What have we got here? Okay, it's drawing a bit of current, which is to be expected. 200 mil. It's climbing. Obviously, things are starting to conduct. Right, what have we got on our B+? Oh, we have vertical raster. It's a good sign. It's meant to be 200 and... That's 200, that's the 240 volt rail, that's the 150 volt rail. I would have thought that would have been a bit higher, actually, to be honest. Oh well, it proves that valves are litting. What have we got down here? It's probably... Yep, that's about right. That's the supply feeding the tube. Okay, it's all looking... You can't smell anything yet. Nothing's burning. Oh, hello! Hey, we have a raster. That's actually bright. Like, it's not fading away. Bloody yolks on the piss. It's probably because it's been knocked when I was moving around. So we'll straight. God, so loose. Yeah, we'll straighten that up a bit. Well, well, well. We actually have a bit of brightness there for a change. There's something seriously screwed up with that vertical, though. That's still... No, it's still not right. Oh, this is good, guys. This is good. This is good. There's no smoke belching out of it. There's no excessive current draw at this stage. I'll just turn on the signal generator, RF modulator, signal source. Excuse me. There we go. That's looking. That's good. It's actually receiving something. Hey, check that out. I might just pause that. Well, well, well. That's a damn sight improvement of what it was, that's for sure. God, that vertical, man, that's the vertical has got some serious issues. Not surprised though. All right, we might just let's just increase the wick a bit. Yeah, that's certainly looking a lot better. Oh, here I was poking fingers at the tube. There ain't nothing wrong with this tube. It's got plenty of life in it. It's good. It's a really good sign actually. Plenty of life on that tube. All right, now that nothing's gone bang, I haven't had my face covered in electrolytic guts or flamed resistors. So measure around down here again. So what's our 240 volt, 245, 240, 231. No, that's still low. It's still going to be 150. It's still low. So that's interesting. What are we on here? We're on... I hate this thing. I really hate it. 218. So essentially about, 220. Let's just give it... Right. We've now given it the full beans. 238 volts. Wow. That is actually... Yeah, that is actually quite bright. Yeah, even I mean the camera is kind of probably making it bright, but that's bright. That's definitely a good tube. How many times I've said that, but I'm going to keep saying it because I can. Yep. Oh, it proves that the IF is working, the video stage is working. It proves that a lot of things are actually quite happy at the moment. Well, reasonably happy. Something's getting hot. I can smell it. I bet it's that 1.5k resistor. Bet that there's getting hot because I get the feeling I've still got problems with this. So what have we got now? It's meant to be 100 and so it's meant to be 145. Well, there we go, 150. There we are. It just needed to be brought up to full mains. Cool. That is good. 245, 253. That's neither here nor there. Well. Okay. Well, this is. Hello. I've just left something unsoldered here. I wonder what will happen when I do this. There's something unsoldered off the board. Left a cap unsoldered off the board. Seems to be doing much though. Holds a bit funky, but you'll probably find there's all sorts of, yeah, the tubes are probably all friggin' dirty and everything. Oh, wiggling the tubes, wiggling the tuner, and the wiggling the valves in the tuner. Yeah, that's not going to help matters, but there we go. Right, well, we're cooking on gas. Cool bananas, as they say. No, nothing appears to be. Yep, that's all good. That's all. Yep. All definitely happy in the camp. Well. Okay, well, I think I think the next thing we will tackle is the vertical, because that is just absolute shit. There's no way you can work with that. That's terrible. I like doing this because my to me it does seem a bit. To me it does seem a bit grainy. I can actually see graininess in that picture there. I can see graininess there. But hey, it's, you know, it's not certainly that's certainly the least of our problems at the moment. We'll get that picture stable. So as you get a rock solid image before we start poking around or checking or adjusting anything else. But no, for now I'm happy. I've done what I wanted to do and proved that this old pile of crap is going to live again, which is good. Oh well, that's good. It seems to be pretty solid now, actually. Yeah, I'm still going to replace those though. I'm still going to replace those capacitors. I still don't trust them. Yeah, we've probably got a nice solid, probably 14-15 kV out of there. I don't actually need to stick my EHT probe under the cap to know that it's giving nice, strong EHT. That's the width control there. Where's that other screwdriver? Because the width control did nothing last time. Oh yeah, it's working this time now. Yep, width control's doing its thing. Yeah, so this was doing nothing last time. So I always like to underrun them a little bit, just to give the old Lopty less of a hard time, and you know, because that's the most crucial, most fragile part of the whole set, really. If Lopty kills over, then the set's pretty much a doorstop. So unless you can get a replacement one or fit something else in there, but no, that's working good. All right, well, I'll leave it here, yeah, I will focus on getting the vertical sorted so we're not rolling. That's horizontal, you twit. Yeah, so get this sorted, and yeah, I will be back with another further update.